Okay, so let's get ready for the test this Wednesday. This is review 3.3. This whole first section is all about compositions. So when you have a composition problem, this one reads F composite G at 7. So I'm going to go rewrite this as F of G of 7. And you're going to do the inside first. So I'm going to go to the G function, which is right here. And I'm going to say G of 7 equals 4 times 7 minus 2. 4 times 7 is 28. And 28 take away 2 is 26. That's your first answer. Now I'm going to take that answer and I'm going to plug it into the F equation. So F of 26 equals the square root of 26 plus 10, which is the square root of 36, which is 6. And remember, your last answer is your final answer. So you might want to pause the video, go try number 2, and then play it and see if you got it right. So this says K composite H at 2. So K of H of 2. Again, we start with the inside. So we're going to have H of 2 equals 2 squared minus 1. So I went right here to the X and I plugged in a 2. 2 squared is 4. 4 times 2 is 8. Take away 1 is 7. That's your first answer. I'm going to take 7 and plug it into the K equation. So K of 7 equals 5 times 7 plus 3. 5 times 7 is 35, plus 3 is 38. Again, your last answer is your final answer. Now 3 and 4 down here, instead of plugging in a number, I'm just going to plug in X. So K of G of X. So I go to my G equation, I take out the X, and I put the X back in. So it really doesn't change at all. G of X equals 4X minus 2. That's your first answer. Now you're going to take the answer that we just got, and we're going to plug it in here to our K equation. So wherever the X is, right there, I'm going to put parentheses, 4X minus 2, just bring that down, plus 3. Now I'm just going to distribute and combine like terms. So I get 20X minus 10 plus 3. So the final answer is 20X minus 7. Okay, one more time. Again, you might want to pause the video and then come back and check. So K of M of X. So M of X equals X minus 3 over 5. That's your first answer. Now I'm going to take that and plug it right in here for K. So K of all this stuff is equal to 5 parentheses, all that stuff. And then you got to bring in that plus 3. Well, it looked like it was going to be hard, but now I can see that these 5's are going to cancel, and all I have is X minus 3 plus 3. And the 3's cancel, so the whole thing equals X. Okay, on Roman numeral 2, they want me to do basically the same thing I did up here, but they want me to do it both directions. They want me to do F of G of X and then G of F of X to see if they both equal X. On your worksheet, there was a typo right here. This whole thing should be over X minus 3, like that. So anytime you have these problems, this is when we write it twice. And then we're going to do it the opposite way. Okay, so I'm going to take my G equation, and G of X equals the square root of X minus 3. And I'm going to take this whole thing and I'm going to plug it in right there. So F of X equals the square root of X minus 3 squared plus 3. Well, anytime you square a square root, those cancel. And I have X minus 3 plus 3 equals X. So far, it's either a yes, yes, or a yes, no. Let's go to the second one. F of X equals X squared plus 3. So I'm going to take this answer and I'm going to plug it in here. So G of X squared plus 3 equals the square root of X squared plus 3. All of this represents the X minus 3. Well, I can go ahead and cancel these two out. So I have the square root of X squared, and again, a square and a square root cancel, so it equals yes. So it's yes, yes, which is choice A. Okay, so we're going to do the same thing again. And again, I'm going to split the paper in half. I'm going to have F of G of X and G of F of X. Okay, so I'm going to take my G of X equation n equals 1 over 2x. I'm going to plug it in right here. So f of 1 over 2x equals 2 times 1 over 2x. So if I do that, my 2's cancel, and I'm left with 1 over x. So not x, it's 1 over x. So that's a no. Let's go do it the other way. So f of x equals 2x. Take that equation and plug it in down here. G of 2x equals 1 over 2 times 2x, which would be 1 over 4x. So this is a no, which is choice B. All right, on 7 through 11, it says decide whether the function is 1 to 1. If it is 1 to 1, find the graph of the inverse, or just write the inverse, depending on the problem. Okay, so for something to be 1 to 1 from a set of points, the x's can't repeat and the y's can't repeat. So 2, 3, 4, 5, so it is a function. Now let's go see if it's inverse. 27, 28, 29, and 30. So nothing repeated, so yes, it's 1 to 1. To find the inverse, I'm simply going to take the x and the y and switch them. So 27, 2, 28, 3, 29, 4, and 30, 5. And that's it. Okay, same thing with number 8, 11, 12, 16, 18. So it is a function. 14, 7, 14. See how these repeated? So it's not 1 to 1, so I don't need to go find the inverse. Okay, when you're looking at a graph, to see if it's a function, you do the vertical line test. So yes, this is a function. And then you're going to do the horizontal line test to see if it's 1 to 1. So this does pass the horizontal line test, so the answer is yes. And then we're going to go graph the inverse. So all you have to do is take a few points and flip them. So I'm just going to use these two. This order pair is negative 4, 0, so I'm going to go graph 0, 4. This is 0, 2, so I'm going to graph 2, 0. And then I'm going to remember it's got to look like a reflection of it. So there is my inverse equation right there. Okay, so it passes the vertical line test. It passes the horizontal line test, so yes. Here's my y equals x line. I'm just going to take a couple of points and flip them. So that says 0, 1, so I'm going to have 1, 0. And this says negative 1, negative 1, so it's going to stay negative 1, negative 1. And then I'm going to go connect them. And that's my inverse. Okay, and on your test, it's going to have the y equals x line graphed. On number 11, it passes the function test, but it does not pass the vertical line test. See how it touches twice? So this is not 1 to 1, so I don't need to graph an inverse. On the next section, it says the function is 1 to 1, find the inverse. So this is when I go rewrite the equation as the y equals. I'm going to go switch the x and the y, and I'm going to go solve it for y. So x subtract 10 equals 4y, and then I'm going to divide everything by 4, so x minus 10 over 4. So f inverse equals x minus 10 over 4. Done. Okay, we're going to do it again. So y equals 3x plus 5 over 4. So x equals 3y plus 5 over 4. And you remember when we had that quizzes, we had one like this, and if you raised your hand and asked me about it, I said, okay, so in order to solve for y, the first thing I have to do is get rid of this 4. So you have to multiply both sides by 4. So then you have 4x equals, these 4's will cancel, 3y plus 5. You're going to subtract the 5, and then divide by the 3. So y will equal 4x minus 5 over 3. So your inverse is 4x minus 5 divided by 3. Okay, last one in this section. Y equals x plus 1 to the third. So x equals y plus 1 to the third. In order to get rid of a cube, you have to cube root the x. And if you cube root this side, they cancel, and you have y plus 1. So y is going to equal the cube root of x minus 1. And that minus 1 is not under the radical. So the inverse equals cube root of x, and then minus 1 is on the outside. Okay, so there's your inverses. On 15 through 17, it says decide whether or not the functions are inverses of each other, yes or no. They don't tell you how to decide, so at this point it's a decision you get to make. You could, if you wanted, do like we did on the front and do f of g of x and see if they both equal x. Or you could simply go solve this equation for the inverse and see if it matches. To me, y'all seem to do better at that, so that's going to be my approach. So all I'm going to go do is I'm going to come over here and say y equals 3x plus 2. I'm going to solve for the inverse. So I'm going to subtract 2, and then I'm going to divide by 3. So I have y equals x minus 2 over 3. Well, dividing by 3 is the same as multiplying by 1/3, so it actually matches. So those are inverses. Okay, I'm going to do the same thing right here. So y equals 5 minus 7x. I'm going to flip them. X equals 5 minus 7y. I'm going to subtract the 5. Okay, and then I'm going to divide by negative 7. So y equals x minus 5 over, oops, I said 5, but I wrote 7. X minus 5 divided by negative 7. Well, this does have an x minus 5, but it also has an x over 7. So that's definitely a no, and it didn't have a negative. Okay, 17, y equals 5x plus 1. So x equals 5y plus 1. I'm going to subtract, and then I'm going to divide everything by 5. So y equals x minus 1 over 5. Okay, well this has an x minus 1, but only the x is over 5. For this to be correct, it would have had to have negative 1 over 5. So this also is a no. Okay, so that takes us through what we did over compositions and what we did over inverses. This last piece is your exponent rules. So number 1, we have negative 4 to the 3rd power. Notice this is not in parentheses, so this means that I'm saying negative 4 times 4 times 4. Notice the negatives on the outside. Well, 4 times 4 is 16, and then we need to figure out what is 16 times 4. Well, 16 times 4 is 64. There's a negative out here, so the answer is negative 64. Now on number 2, it's a little different because the negative's on the inside. So it's saying negative 4 times negative 4 times negative 4, and I have a negative exponent. So I'm going to go rewrite it like this to make it a positive exponent. And because the negative is on the inside, a negative 4 times a negative 4 is a positive 16, and a positive 16 times a negative 4 is going to give me a negative 64. Okay. Number 3, this time I have a negative exponent in the bottom, but I am not allowed to have negative exponents, so I simply move it to the top, and I get c to the 3rd over 1, which is just c to the 3rd. On number 4, we have c to the negative 3, but this time it's on top. So in order to make it positive, I have to move it to the bottom. Once I move it to the bottom, I have to put a 1 on top to hold the spot. Number 5, I have a negative 6d to the negative 5. The only exponent that's negative, or let's say 3, I'm sorry, d to the negative 3. The only exponent that's negative is the d to the negative 3. This negative 6 is not an exponent, so it stays where it is, but the d to the 3rd is going to move to the bottom. Right, number 7. We've got a bunch of negative exponents, but before I mess with those, I'm going to go take care of my power to power rule, which says I multiply. 3 times negative 7 is positive 21. Negative 7 times 6 is negative 42, and then I have c to the 10th. Because I have a negative exponent, it needs to move from the top to the bottom. So I have a21, c10, all over b to the 42. Number 8, on the top I've got multiplication, so we're going to add our exponent. So I'm going to have a to the 3rd, 2 plus 1, and then I'm going to have 5 plus 1 is 6, all over. Now I've got power to power, so I multiply. 2 times 6 is 12, and 2 times 1 is 2. Okay, so I had multiplication on top, I added the exponents, I had power to power on bottom, I multiplied them. Now I've got division, and we're going to subtract. So I have a's on top and bottom. I have more on the bottom, and 12 take away 3 is 9. I have b's on top and bottom. I have more on top, and 6 take away 2 is 4. Okay, number 9. Again, I have a negative exponent. I only move the negative, so I'm going to put a 1 on top to hold the spot. On the bottom, I have a6 and a5. Because I'm multiplying, I'm now going to add them, and I get 1 over a to the 11th. Okay, if it were me at this point, I would pause the video, and I would try to do the next section, and then come back and check your answers. Okay, so on number 1, you have negative 4 squared. 4 squared is 16, but there's a negative here, so the answer is actually negative 16. Number 2, we're going to have a negative over 4 squared. So the negative stays, and only the 4 to the second goes to the bottom, so it's negative 1 over 16. Negative 5 to the third, again, you're going to have a negative. You're going to have 5 times 5 times 5. 5 times 5 times 5 is 125, and because there's a negative, it's negative 125. Number 4 is almost the same problem, but it's got a negative exponent, so we're going to have a negative 1 on top, and a 5 to the third on the bottom, so it's negative 1 over 125. Number 5, it's a lot like number 9. I'm going to move that x to the 7 to the bottom. So I have x to the third, x to the 7. I put a 1 on top to hold the spot. I'm going to add my exponents on the bottom. Number 6 is kind of the reverse of what we just did. I'm going to move that negative 2 to the top. So x9, x2. Give me x11. Number 7 is a lot like number 4. I've got a negative exponent, so I'm simply going to move it from the top to the bottom. And I put a 1 on top to hold the spot. Okay. Number 8, there is absolutely nothing to do. Don't really know why that one was there. It's done. It's simplified. Number 9 is not simplified because you have a negative exponent right here. So the negative 3 stays on top. The x squared moves to the bottom. Remember, I can have a negative number. I cannot have a negative exponent. Number 10, I'm going to distribute. And I'm going to get x to the negative 28, y to the positive 28, w to the third. The 28 and the 3 are fine, but the x to the negative 28 has to move. So when that happens, I'm going to have y to the 28, w to the third, all over x to the 28. Okay. Same exact process right here. So I'm going to have x to the 20th, y to the negative 12, w to the negative 3. The two negative exponents are going to move to the bottom. So I'm going to have x to the 20th on the top, y to the 12th on the bottom, w to the third on the bottom. Number 12 is a lot like number 8 on the top. So I'm going to multiply, and when you multiply, you add exponents. So x3 and x1 is x4, y10 and y1 is y11. Down here, I'm going to multiply and get x10, y8. Now, because we're dividing, we're going to go subtract. I have more x's on bottom. 10 take away 4 is 6. I have more y's on top. 11 take away 8 is 3. All right, 2 more. So number 13, I've got a negative exponent, so it's got to go from the bottom to the top, so it's just going to be x squared. On number 17, the z is going to move up and the y is going to move down, so it's going to be z to the 5 over y to the third. And that's it. So your test is tomorrow. Watch the review a couple of times, work with the review a couple of times if you need to, and study. Good luck.